Okay, so now let's get into the expanded model of a computer. We're still in module 2.1, basic concepts of computing, and this is lesson 2 for that module for grade 10 information technology, and let's get stuck right in. So now we're going to talk today about the expanded model of a computer. Okay, so we're going to take a look at how the computer actually works in greater detail. So the IPO model that we were talking about in the previous lesson, input, process, output, it kind of oversimplifies complex operations, as I spoke about towards the end of the lesson. Every part of the computer, internal part of the computer, has a specific job, as well as every external part of the computer has a specific job that relates in some way to either input, process, or output. Each of these components are systems in and of themselves and follow the IPO model in their own way. And I kind of talked about that towards the end of the lesson, but I kind of breezed over it. But just to reiterate, when you think about it, as we learn these components, or as we learn about these components going forward, you'll see that each of them are technically systems, the same way that making toast is a system from the previous lesson. So each of these components are systems and do follow the IPO model. They do receive input, do some process, and receive some output, but they all also at the same time a larger part of some greater process that's taking place to do with our computer being a multi-purpose electronic tool. So the main components that we're going to be talking about right now include input and output devices, storage devices, processors, memory, and communication technology. Now, we're not necessarily going to talk about communication technology right now. We're going to actually come back to that in a future chapter where we talk in detail about networking. But for now, just note that your computer is technically connected to and part of a network of other computers, and the way that it does that is using what we call communication technology. But we'll come back to that. For now, we're just going to talk about input and output devices, storage, processors, and memory. So let's get to it. So the first one that we're going to talk about now is input devices. So these are devices that allow us to get data into the computers. As I was talking about just now, right now, my microphone, as we see here, we've got a picture of a microphone over here. I've got a microphone over here that I am talking into, and it is receiving my audio as input, where it's being processed by the computer and saved as audio information. We also have our keyboard and mouse, which is the primary way that we get input into the computer. We also have webcams that receive video input, game controllers that receive game, joypad information for playing a video game, scanners for scanning documents into computers, pen tablets for digital art, and also touchscreens. Interestingly enough, if you're looking at your phone and trying to determine, well, what's the input device here on my phone, the thing that's allowing us to get data into the computer, besides, of course, your cameras and your microphone, is the fact that it's got a touchscreen. That touchscreen is an input device, or is the input device of your phone. I mean, it's integrated, as we say, it's an integrated computer. The touchscreen is built into the computer itself, but it's still its input device. It's how we're getting input data into the computer. So that's input devices. So same way we have input devices, we have output devices, devices that display some data from the computer. So some examples of this would be our monitor that we're looking at right now to watch this video. That's outputting information from the computer. Printers as well output, they output documents from the web, or not from the web, from wherever we want to print from. A printer will print that page or print that document. Projectors, same thing as monitors. The only difference is that they project light onto a screen. Headphones as well, when you listen to your music coming out your computer, that's an output device. And likewise, speakers, of course, same thing. Loudspeakers are as well output devices that are allowing us to get feedback from the computer, hence output devices. Okay, so now we start to get into the technical parts of the computer. So let's just talk quickly about storage devices. So storage devices allow us to store instructions and data long term so that the computer can access it when it needs to. So right now I've been talking a lot about data coming into the computer through input devices, and I've kind of been talking about it very generally and very loosely, but really what you need to know, and we're going to talk about this when we get to the software section, is that all programs and data on your computer is just a set of instructions, okay? And those instructions need to be stored somewhere long term on the computer, so that when we turn off the computer and then turn the computer back on, the instructions are still there in a way for us to retrieve them. And this is where we get into storage devices. So I'm kind of taking a long way to explain a very simple concept here. When you know hard drives, okay, you know that your phone has storage, you know that your phone has a hard drive, and if you save too many photos and videos on your phone, what happens? You run out of storage space. So what that whole concept is what we're talking about here. These storage devices, the thing that's actually storing that information for you. So some great examples of this would be hard drives. So this right here is a hard disk drive. We'll talk about these in the hardware chapter in a couple of weeks, but these are magnetic drives that use tiny little magnetic traces to save your data on the computer. If you have a desktop computer, odds are you either have one of these devices or you have one of these solid state drives, which is essentially the same thing. It's just a lot more expensive, but a lot faster, and also generally speaking has less storage space than a hard disk drive. But we'll talk about that in the future. Don't worry about that. All you need to know is that we have these two kinds of hard drives. We have these hard drives and then these hard drives, and we'll talk about them in more details later. But what you need to know is that they're both storing information long term. Then moving on, we also have these USB scan drives, these scan disk ultra compact flash disks, these SD cards as they're known for cameras and for cell phones. This is additional storage that you're putting into your computer. You're also getting things like these CD drives. Now this is kind of dated technology, CD and DVD writers, but absolutely, if you have a CD and you're putting that CD into a computer to read some information off it, it is a storage device and you're using it to store data, and therefore is what we're talking about here. So another thing I didn't have a picture of is an external hard drive. I'm sure many of you have external hard drives. If you have one of those, that is a storage device. It's just not an inbuilt storage device. It's an external storage device. So we'll talk about that in more detail later on. For now, just know that storage devices allow us to store instructions and data long term. So now let's move on to the processor. Okay, so this is where we start to get into some pretty deep level computer stuff. This is where we're really starting to get into IT here. So the processor, or as it's also known, the CPU, which stands for Central Processing Unit, but you don't need to know that now. All you need to know is the processor is the CPU. So the processor is the part of the computer that executes the sets of instructions that we view as programs and computer operations. It processes data and manages and controls all aspects of hardware and software. So this little CPU, you can think of it as the brain of your computer. It's kind of like what is responsible for whenever we talk about, the processing step of the IPO model. When we talk about the processing step generally, we're talking about the processor doing all of those tasks. When I say that a program is just a set of instructions that need to be processed, the CPU is the actual thing that is doing that processing of those instructions. So the way that it works in explicit detail gets a little bit tricky to understand. So we're not going to get into deep details about that right now. We'll get into some more details about it when we come back to the hardware chapter in a couple of weeks that I keep alluding to. But for now, all I need you to know is that this processor, the CPU, it's the part of the computer. It's one of the most important parts of the computer because it is the thing that is literally doing most of the control and management of the computer. Whenever we run a program, when we turn on our computer, when we load up our operating system, which we'll talk, when we load up Windows or Mac, the CPU is doing all of that. When we have to retrieve something from storage, the CPU is doing that. When we have to run a video game and process some graphics, well, I mean, technically speaking, the graphics card is doing that, but I don't want to confuse you now. Basically, you can assume that all of, a lot of the stuff that has to happen with the processing of that video game, or maybe we can say just Steam itself, Steam loading the video game, that has to happen with the processor. So here we have some examples of some processors. So we've got these Intel Core i9s. You'll probably find that most of you will have Intel CPUs in your computer. or Intel processors in your computer, you'll know because there's a little sticker on your computer that says Intel inside. That mean that then you know that you have an Intel processor. This is a Core i7, which is a pretty decent processor. And then you'll see also over here on your motherboard, as we call it. This is a motherboard. We'll talk about that in future detail. It's the central circuit board which all of the other components on the computer connect to. Your CPU has its own little house that it gets put into and kind of like presses down, and we'll talk about that in more details in the coming weeks. And you can also see the backside of these CPUs there. They have these little contact points that push down and connect to a bunch of other contact points that correspond to the same points. You see there's a specific way you have to put it in. You can tell by those notches on the CPU which way you're supposed to put it in, or what orientation you're supposed to put it in. Yeah, there used to be, interestingly enough, little points on the end. It was like actual like sticks sticking out of those points that you had to press in, but they were very delicate, and pins, as we called them, they were very delicate, and they broke for very little reason. Just small amounts of pressure would break them. So we've moved over now to these contact points, thankfully. So that's the processor. So now the processor, it's important to note, has a friend. Okay, and whenever you think about the processor, I want you to think about its best friend, and its best friend is called memory. Okay, so memory is also known as RAM, which stands for random access memory. We'll talk about that in a couple of minutes, but for now, I just want you to know this term memory. Okay, now I need to tell you right now off the bat, okay, memory and storage are two separate concepts, okay? And I'm telling you that now because you need to learn that as quickly as possible and as soon as possible. Storage is where we store instructions long term, okay? But memory is the place where the computer temporarily stores sets of instructions that it's currently working with. Now, I'm going to get into more detail about this in the coming weeks, but basically, the reason why we have memory is because storage, the hard drive, is much, much, much slower than the CPU. Okay, the CPU is possibly in some cases tens, hundreds of times, or somewhere between those numbers, faster than the speed at which storage can save and retrieve information. So what would be happening is, if we wanted to just keep everything in storage that we were processing, because we have to store large sets of instructions, the program, to process it, and we need to store that instruction in the meantime somewhere where the CPU can process it. And if those instructions were just being retrieved from storage, it would take much longer to retrieve and process those instructions than it would if we just had some kind of high speed storage that sat very close to the CPU, so that we didn't have to worry about that read-write time that would slow down the entire system. So this is where we get into memory. So like I say, memory is the place where the computer temporarily stores sets of instructions that it's currently working with. And you can see on this picture down here is we actually have some sticks of RAM connected to the motherboard, and it's right next to the CPU. So you can remember the CPU has a best friend, and that best friend is memory, or RAM. So instructions, programs, data, it can only be processed if they have been loaded into memory, okay? And that's important to know. It's just the way that the computer is wired. It's the way the computer is built. It's the way the computer is designed. You can't actually run something straight from storage. It has to be loaded into memory first before it can be processed. So we can see some examples of memory here. We've got, I think when I just Googled best current RAM, and the first image result was this. I don't know if it's actually good, but you can tell this is like some RGB gaming RAM or something crazy. And then here we've got some more dated RAM, but you can see RAM always comes in these little sticks of RAM. So you say, I'm going to buy a stick of RAM, and then one stick of RAM is like, say, 4 gigs or 8 gigs, or, in some cases 16 gigs. And then you can put a whole bunch of sticks of this RAM into this computer, and it will, the more sticks of RAM you have, the more RAM you have, and the ultimately more instructions you can save, and the faster the more instructions you can hold temporarily, and the overall faster your computer is. And we'll talk about that in the next section. Don't worry about that for now. All you need to know is that memory is the place where the computer is temporarily storing sets of instructions that it's currently working with, so that we don't have to deal with the bottleneck that is the slow speed of storage. So little bit more about RAM quickly, or about memory. As I said, it's commonly referred to as RAM, so random access memory. If you hear people talking about memory, or if you hear people talking about RAM, it's the same thing. Sometimes people don't get the distinction well enough, and they, colloquially refer to memory as storage, and people don't generally refer to storage as, they don't generally refer to memory as storage, but generally some people refer to storage as memory. But us in IT, we're going to get pedantic about that, and we're going to get specific and say that RAM is, or memory, when we talk about memory, as the short-term high-speed storage, and storage is long-term, slower, long-term storage. Okay, so programs have to be loaded, transferred from storage to memory before they can be processed. I did talk about that in the previous slide, but it's just worth noting again that programs have to be loaded. Okay, they're transferred from storage to memory and are then processed by the CPU. And it's also important to note that the contents of memory are volatile. Okay, that's a great word, volatile, which means that they need to be transferred to storage before they can be considered saved and permanent. Because interesting thing about RAM is that the moment that the computer loses power, it's over. Everything that's in memory gets drained and gets lost. So the contents of memory are volatile, as we say. The moment the computer loses power, everything in your RAM will be lost, which is why if you're working on something on the computer and, the computer crashes or the computer shuts down for some reason, whatever you were working on probably won't be saved because it was stored temporarily in RAM, not committed to long-term storage when you clicked save. So normally when you right-click save as, what you're doing there is saving it to storage. But up until that point, before you save it the first time, it's just existing inside of memory where it could be lost at any given moment. So that's RAM. Let's just quickly talk about hardware and software, just because I haven't really spoken about it yet, and we're going to be talking about software in the next video. So hardware is what we've been speaking about so far, okay? It's the physical parts of the computer that you can actually touch. This is what we classify as hardware. So these are internal components like the ones that we've just discussed, but also external components like the ones that we've just discussed, like keyboards and screens. So, internal components, memory, processors, storage, all of that's inside our computer, be it inside of our phone or inside of our computer case or inside of our laptop. All of these devices have these three components, and they all, they're all considered hardware because they're actually physical components. But software. Okay, now when we talk about software, this might be pretty obvious for a lot of you, but software are the programs that are installed on a computer. So when I talk about software, I'm talking about the things that exist only within the functioning hardware computer. So, like I said, system software like operating systems. So, Windows, Mac OS, OS X, Android, Linux, if you want to roll that way, or Ubuntu, as we'll talk about in the next lesson. These are these are examples of system software. But then you also get application software like video games and Microsoft Word and Google Chrome and Steam and OBS and the Adobe Suite, Photoshop, Premiere Pro, things like that. Really, software is just a set of instructions for a computer task, with every step broken down into extreme, excruciating detail. And we'll talk about that more in the coming weeks. But just to give you a heads up for when we get to programming. Really, a lot of what programming is this concept of taking a basic set of instructions and breaking them down into as much detail as possible. And that is ultimately what a software is, what a program is just the process that the computer needs to take to accomplish a task, broken down into excruciating detail. And that's what we're going to talk about in the next lesson, the role of software in the context of the basic concepts of computing. So I'll see you in that lesson. Take care.